Sierra Institute Wood Entrepreneur Program, welcome to glorious Southwest Colorado. We got lucky this morning. There's a few clouds. That's super rare for us. We're also really lucky right now in that we're not on fire at the moment. But this is the facility on which Timber Age exists. This is Salt Creek Farm. And you can see the beautiful La Plata Mountains in the background here. And we are excited to be with you all today. Thank you so much for the opportunity. For the folks at the Sierra Institute Wood Entrepreneurs Program, we're pretty rough and ready around here, and you'll see just how small we are and kind of what our vision looks like for recreating timber industry jobs at a really small scale, or wood utilization at a small scale. We're going to take time over the next few minutes to just walk you through the general layout of the facility, the process that we go through to create small scale CLT out of ponderosa pine, and show you some of the innovations that we've worked on that have helped us stay small and be community fit and work at a scale that fits the community and the forest that exists here in Southwest Colorado. So you can see here going on in the background, we're out of logs at the moment. We're still working on log hauling and log sourcing. So it's sort of a daily thing of making sure that there are logs in front of the mill. But we've got our team member Connor, team member Sean. They're moving the last couple of logs that we have here. Connor's in the process of taking the resaw attachment off of our LT50 Super. And this is it. This is our one and only sawmill, and everything we make comes off of this mill. So the general layout here being logs come in, we use fairly small scale material, especially considering that we make cross laminated timber. We use 11-foot long ponderosa pine saw logs down to a 7-inch diameter top. It's what the majority of our forests here locally are. It's material that comes predominantly, almost exclusively from fire mitigation work. So it's a lot of small diameter material, some of it bug killed, some of it not. And I would call these substandard saw logs. We work with pretty rugged logs sometimes. And we've just built out basically a sawing operation that is totally fit to our scale. And so it's fairly small, it's dense. Once rough sawn boards come off the sawmill, those that can go into the drying process are stickered and stacked. The team created kind of a neat slab rack out of some old tubing, and we'll put together about a cord of slabs at a time. Those are banded up and go into a laydown yard to be sold as firewood.
So previously we had, a really rudimentary rack just right over here where we could put all of the boards that had too much weight on them to be able to use in process that needed ripped down. They just all get stacked up, and especially with this new mill, with this track on this side, reaching over was getting really hard on the body. So we decided to get version 3 of our slab rack over here that we call Wayne's World.
Walk over there. And why Wayne's World?
Because the pieces on the edge of these boards with all the bark on them that we can't use is called Wayne.
Very good.
So we developed this guy where we can actually start to sort, different sizes and of boards that need ripped down, and even down to different amounts of work that each board is going to take to get it to a usable piece of wood for us. And we brought it off the back of the mill to hopefully make the process of loading those boards onto the mill to be processed a little bit easier.
So this is our one and only solar kiln at the moment. We're actually just about to start the construction of 3 more. This is based upon the Oregon State design that they originally mounted on a trailer and did some mobile demonstrations of. We just modified it slightly, and we found that even this simple design can cut our drying time here in very dry, very arid Southwest Colorado in half. And you'll see some additional steel at the top of the frame that was put up there purposefully to mount photovoltaic panels on. We now know the load it takes to run the automation and the fans on the kiln, and it can be run off grid. This siding? Yeah. This is us testing the way to take green ponderosa pine and make bevel lap siding and just see how much it moves. It curls. It's like snail shell. So this kiln holds just a hair over 65 cubic feet of boards. As you can see, we rough saw 5/4. This kiln is equipped with weigh sensors, so we actually know the weight of the load as it goes in, and we know the optimal weight of a dry charge at 65 cubic feet. There's no heating element on this kiln. There's no heat pump. It's simply taking solar gain and increasing the temperature inside, and we're just exchanging cooler, drier air for warmer, moister air. It's okay. So there is a little bit of automation included in this kiln. We kind of took that Oregon State design and added a few things to it. So there's a programmable logic controller that helps us operate the kiln. It is connected to Wi-Fi network, so we can monitor the kiln remotely. But basically what we're looking for is that we know that a charge of ponderosa pine 65 cubic feet needs to weigh essentially 1,700 pounds when it gets to roughly between 9 to 15% moisture content. And so it just helps us, track the kiln on a daily basis. So one of the things, working with non-standard timber, kind of bringing ponderosa pine back into the entire timber supply chain, is that things are always changing. We're always prototyping. We're dealing with a lot of different seconds and rough cut material, and we're finding that there are little niche markets throughout our community for this kind of material. So one of the things we would encourage you all to think about is not just your main product, but all of the ancillary things that are going to come out of whatever manufacturing you're doing. So do you end up with material that can be used board and batten on agricultural or livestock buildings? Is there some material in here that can be used for fencing, something to that effect? And so we know that there are markets for these kinds of materials. Here in Southwest Colorado, the timber industry went away so completely that it's a little different than Northern Sierras, and we're just now beginning to bring some of those things back to life. So it's super common for us to be able to sell the material shown here in bits and pieces. and it's not a main stream of revenue for us, but at least it's not becoming a waste. So failure is your friend. Do not be afraid to fail. This panel down here that's completely delaminated was a meltdown in our vacuum pump and press in the midst of putting a panel together. And, you know, we learned, right? And so it sits out here right now, and we'll cut it up and use it for something, but do not be afraid to fail. And, you know, keep your early prototypes around. These were wall assemblies that we put together to create the first insulated version, kind of combining SIP technology or SIP concepts with CLT. And I would just say, take every one of the pieces of material that doesn't come out the way you want it to come out and do something different with it, because chances are you'll invent something or come up with something new and innovative that you haven't even thought about yet. So here we are at the actual CLT manufacturing shop. It's a 1,200 square foot steel building. You can hear the planer going on in the background. Believe it or not, we can produce over 60 cubic feet a day out of this shop. So our team member Fernando is in here working right now on planing some boards that are going to go into a 4 foot by 8 foot panel that's actually going to go to a museum in St. Paul, Minnesota. Let's go inside and we'll have a look at kind of how our process flow works. Rough sawn boards that are dried to a 9 to 15% moisture content come into the shop. They're loaded in with a skid steer. There's marks on the floor so we know exactly where this bunk of wood needs to go so that we can maximize the amount of space in the shop. At this station, the boards are cut to length, depending on what size panel we're making. They might be 10 foot long lamina, 5 foot short lamina. If we're making a 4 foot by 8 foot panel, we can make adjustments to the clamps. But as you can see, it's a super simple setup right now. We're working on an automated chop saw, but for now, keep it simple. Start with the least expensive experiment that you can come up with. From there, the boards slide down, go into the Woodmiser MP360 molder planer where we get S4S material. I'm gonna get out of Fernando's way. Okay, you've seen a bit of the chop saw station and the planing station. From there, the now planed boards are going to go onto the layup table. So this is kind of the 6th generation of a wooden table that we've created. We're just now committing to steel because the design has settled down. We have to replicate a lot of designs before we commit to a more expensive material. You see boards here that are getting laid up. We're going to do a test layout before everything gets glued. So we've had to get super creative with what kind of tools we use to create CLT at a smaller scale. We do not have a CNC machine at this point. All the panels are finished by hand with hand tools. And so in that process, we've had to design this a 3D printed router jig that allows us to do a center spline on a 3-inch panel. It keeps the router centered on the panel to make sure that the spline goes in the exact correct place. So that was internal 3D printed. The Makita track saw that's just come out allows us just enough clearance to cut a 3-inch panel. We started originally with the Makita 16-inch beam saw. We call this thing Jaws. It's an absolute nightmare to handle, but it allows us to cut a 5-lam panel if we have to. We encourage the creation of learning and teaching tools. This was a demo and a tool that was put together for our team to sort of illustrate how multiple splines are going to come together in panel-to-panel connections, because we're going to pre-install splines where necessary before a panel goes out to a job site. So when we first started putting CLT together, we were using the DR Johnson model of like paint bucket, paint roller, you know, taking examples from things people had done in the past. And it's evolved a half dozen times or more already. Where we're currently at with glue application is that this is a 3D printed glue applicator tip that's sort of custom fit to our panel dimensions that we've created and designed. It's got 4 apertures and printed it in 2 pieces so that the glue comes in and it's under slight pressure and the glue's warmed up to temperature, and this screwed into a broomstick and the feed hose from the glue drum allows us to put the appropriate glue lines onto the boards before they go into the press. So start simple. So we've dropped from a 60-minute glue to a 45-minute glue, and we are now down to a 20-minute glue. You can see just how fast these guys are moving. And at this point, you know, our goal is to be able to consistently use this 20-minute glue, even in a fully manual process. And the faster glue we use, the more panels we can produce in a day. The other thing that you'll see here is that the clamps are color coded. These guys are constantly innovating in the shop, and so one of the things that they've done is that white tape to white clamp, yellow tape to yellow clamp, red tape to red clamp, to make sure each clamp goes in the correct position, in the correct order. And just like that, there's a CLT panel in the bag. I mentioned that we use 20-minute glue. So after we're up to full pressure, this panel is going to need to stay in the bag for approximately 78 minutes. The vacuum pumps are on a timer. So once they're up to full vacuum, the timer is going to kick in. It's going to keep at full vacuum for approximately 78 minutes. Then the pumps are going to kick off, and it takes an additional 24 hours to allow the panel and the glue to cure before it can be used in a structural fashion. So the panels come together. It's going to stay in the bag until the glue is fully kicked. From there, we don't have another panel to demonstrate at the moment, but the panel comes out of the bag onto a rolling cart to, you know, it's people first. Make sure that you're taking care of your folks. So think about lifting and ergonomics. What can you use, you know, in mechanical fashion to reduce the impact on your people? Panel is going to come from the press onto the table. This station in the shop is sand, spline, and size. Panel will be cut to each specific size at this location. From there, you know, if this were a full-size panel, it would be sized, splined, surface sanded if that's what the client had requested. And then from there, it actually goes to one more station in the shop, and this is the evolving station that we're in the process of producing insulated panels that are kind of combining the concept of a SIP with CLT. So what you see here is a model, a mock-up of some panels we've actually built, where you've got 3 inches of CLT, an 11 7/8 TJI, tight packed cellulose insulation in this bay, the weatherproof membrane, battens, and then metal roofing. So this is a panelized system that can be completely shipped to the job site ready to go, where you've got everything from your structural CLT out to your cladding ready. Okay, so part of being in a rural environment is that you may not actually have all the utility that you need. In this part of La Plata County in Colorado, there isn't three-phase electricity. And so we talked to the power company. They wanted an enormous amount of money. We can't afford that, but we could afford a 100 kilowatt diesel powered generator. And we produce our own three-phase electricity. And we just recently built the sound shed around this so that the family that lives on the farm is not nearly as, the impact on the family goes down substantially. But, in this case, we had to get creative. What can we do to create our own electricity to be able to run the tools that we need in the shop? So here's our generator. And then, as anybody in the wood products industry knows, one of the greatest things you have to consider is the very end of your process. What are you doing with your chip? What are you doing with your dust? Right now, we've got a chip extraction system on the shop. We do not have a bag house and we do not have a cyclone. So chip goes directly into a chipper truck. And this dust and chip goes to a commercial compost facility that's just a few miles down the road here in the county. So one other thing that, anybody that works with CLT should be aware of is just the sensitivity to temperature control between the boards themselves, the ambient temperature in the shop, and the temperature of the glue. So one other thing that we have access to here in our little manufacturing shop is that this is a wood-fired boiler. We actually take the scrap from the manufacturing process, and in the wintertime, this boiler provides hygronic heat to the shop so that we can ensure that the wood, the glue, and the shop are of consistent temperature, so that we make sure that we get proper glue adhesion.